recorded.
Hello to everyone and welcome to today's webinar. My name is Tanner Swift and I'll be your moderator for the session. We have a few wonderful speakers ready to share some information with you all today, but before I hand the mic over to our presenters, I do have a few housekeeping items to cover about this presentation. Today's webinar will be recorded and made available on demand after the live session. We will provide you with some of those details at the end. Also, we'd love to hear from you during today's presentation. During the session, if you are here on WebEx with us and have any questions for our presenters, we ask that you please submit those questions through the Q&A panel. It allows us to filter those questions better into where our wonderful panelists can give you a response. If you experience any audio issues today, we ask that you please try to rejoin the session. And if to no avail, please use the call-in number displayed on the chat screen. I will post that once again momentarily. So without further ado, I would like to welcome our speakers and first kick things off by sending it over to Marius. Marius, right over to you.
Welcome everybody to the session today focusing on SRv6. Some of you might know that in the previous session, my colleague Alexei covered the way on how to configure SRv6. And today's session is a continuation of the previous one, where we're going to focus on how to migrate to SRv6, considering that you have today MPLS and you're going to have a migration path after this session. Your presenters today are Alexei Kirichenko, Solution Architect in CX Product Management, Jakub Horn, Principal Technical Marketing Engineer in the Business Unit, and myself, Marius Stoica, Product Manager for Customer Success. The agenda for today is focusing on different topics like MPLS to SRv6 migration. I'm going to give you an overview. After that, Alexei and Jakub will dive deeper into what is available today and what will be available tomorrow. So let's get started. 20 years back, we were slowly moving from flat IP networks towards MPLS. Today, we evolve our MPLS networks towards SRv6. Let's see why. First of all, we have some challenges today, like the network scale. The network scale, when we look at the MPLS, we started from allocating a label per prefix. After that, we started by allocating labels per VRFs, then per CE. And even with those improvements, we ended up by running out of the million labels that we can allocate. This was not enough. If we look at the protocols, always having an LDP with an IGP sync and trying to control the complex stack of protocols was a problem for quite a lot of service providers. For this, we propose SRv6. Moreover, did you ever configure traffic engineering in MPLS with SVP? Oh, that was such a nightmare. SRv6 is making the things way nicer. First of all, we're going to simplify dramatically the protocol stack and the way that the IGP works, because in the IGP, we're going to transmit all the information necessary. On top, we're going to run the same services that are running today on MPLS. We're going to be able to run them on SRv6. We can do IPv6 summarization, providing the fact that we did our IPv6 addressing right, and we also have a service interworking gateway that would bridge the gap during the migration between the SR-MPLS or MPLS-based networks and SRv6 networks. So let's look at the overview of the migration, and after that, Alexei will dive a bit deeper into the migration steps. Let's start with the flat network where we're running ISIS, LDP, we have BGP VPN, and if we need an intra-domain connectivity, we have BGP-LU. From this point, we're gonna focus on how to configure ISIS and what will be the steps. First of all, we're gonna need to go and enable SRv6 and IPv6 on all the locators, all the routers in the core. There is no need for the removal or modification of any existing configuration. Everything is running as designed. We're just adding configuration on top. Current services are staying the same. The nodes are just becoming IPv6 forwarders. And we need to check in this tab that we have IPv6 and SRv6 end-to-end reachability. Between domains, we can summarize IPv6 prefixes. There is still one step that we need to do before that. We need to make sure that we're having the proper loopback addressing and the addressing of the locators. Why? Because if it's not done according to the best practices, we cannot summarize them in one go. When we have the entire network configured, we can add the route reflectors. And by adding the route reflectors, we're gonna start to send the routing information not only to the VPN-v4 or the IPv4, let's call them like that, route reflectors, but we're gonna send the routing information to the SRv6 route reflectors. You can see a difference in the color over there. With this, we're already ready to start the migration. And the migration will be a simple step. Starting from the P's, we're going to start to change the attributes of the BGP routes that are being sent to the route reflectors in order to prefer the SRv6 route over the MPLS route. With this method, we can migrate the P's step by step, and we can do the test at all times. Very, very important. The migration is going with 0 packet loss. At the end, we can remove all the MPLS routing protocols, and all the services are SRv6 based. And again, this is happening with 0 packet loss. I'll hand it over to Alexei, and he will tell you a bit more about how the things are happening in the back. Alexei?
Thank you, Marius. So the scenario described by Marius is named dual connected PE. And a PE is connected to both worlds, MPLS and SRv6. So dual connected PE feature allows the PE router to support IPv4 3 VPN services for a given VRF with both MPLS and SRv6. For our visualization, we show MPLS and SRv6 separately here. So on the slide, node 2 is a dual connected P providing MPLS L3 VPN between site A and site C, and SRv6 between site B and site C. Dual connected PE uses SRv6 behavior in SRv6 domain and MPLS behavior in MPLS domain. And hence, to reach site A, it will use MPLS stack, and to reach site B, it will use a SRv6 locator. Here we see how data plane works in both domains. To reach devices on site A, where the MPLS core, the dual connected P will use MPLS stack. And we can see a packet with a blue header and a stack of MPLS labels. To reach devices on site B via SRv6 core, the dual connected P will use a SRv6 locator. And we can see a packet with a green header and a SRv6 microseed container placed in the IPv6 destination address. Here we can see dual connected P configuration example. Again, we use different route targets here just for demonstration purposes. We have our VRF and add import and export RTs from MPLS and SRv6 domain. We use column 1 for MPLS port and column 1000 for SRv6 site. Here is the BGP configuration example for the dual connected P. So we see two neighbors. One in MPLS with IPv4 address, and another SRv6 with IPv6 address. Address family is VPN v4 for both, as we connect the same v4 services. Under BGP vref configuration, we specify we'd like to allocate MPLS label and a SRv6 seat. Let's move to next scenario and see how we can connect services in MPLS and SRv6 domain together. That should be considered as a temporary solution during the migration. SRv6 MPLS service interworking gateway enables you to extend layer 3 services between MPLS and SRv6 domain. The feature allows a way to migrate from MPLS of 3 VPN to SRv6. The service interworking gateway provides both transport and service termination at the gateway node. The gateway generates both SRv6 VPN seeds and MPLS VPN labels for all prefixes under the VRF. The gateway supports traffic forwarding from MPLS domain to SRv6 domain by popping the MPLS VPN label, looking up the destination prefix, and pushing the appropriate SRv6 encapsulation. From SRv6 domain to MPLS, the gateway removes the IPv6 header, looks up the destination prefix, and pushes the VPN and next hop MPLS labels. In the slides, we put more detail on how it works. In the SRv6 domain, the control plane advertises IPv4 prefix with the assigned SRv6 seed. The same prefix gets MPLS label assigned by the interworking gateway, node 4 on the slide. And the gateway re-advertises the same prefix into the MPLS domain with the assigned MPLS label. P7, which is in the MPLS domain, will use the label assigned by the gateway node 4 to reach site B in SRv6 domain. Here we can see the data flow from MPLS into SRv6. So site A sends traffic to site B7 encapsulates incoming traffic with MPLS stack. Then the gateway node 4 pops the MPLS VPN label and looks up the destination prefix. Next, it encapsulates the payload in an IPv6 header and sends it to P5. P5 removes IPv6 header, looks up the payload destination address, and forwards it to site B. Here we look at the other direction, SRv6 to MPLS. In MPLS domain, the control plane advertises prefixes with the assigned MPLS label. This same prefix gets a SRv6 seed assigned by interworking gateway node 4. And the gateway re-advertises the same prefix into the SRv6 domain with the assigned SRv6 seed. P5, which is in the SRv6 domain, will use this seed assigned by the gateway node 4 to reach site A in MPLS. Here we can see SRv6 to MPLS data plane. P5, which is in SRv6 domain, encapsulates the payload in an IPv6 header with destination address of the gateway node 4. The gateway node 4 removes the IPv6 header, looks up the destination prefix, pushes the MPLS stack, and forward it to P7. To site A. Configuration is similar to the dual connected P, but now we use stitching keyword to stitch MPLS RTs to a SRv6 domain. And here is the configuration example for the gateway. We add configuration to import the stitching RTs and re-advertise them to a different domain. And with this, I would like to hand over to Jakob to explain further and on MO6 with MPLS over SRv6.
Hi everyone. The Marius have shown you how to migrate single domain from MPLS to SRv6. Then Alex have shown you how to connect two independent domains, which one is going to be SRv6 only, and second one would be MPLS only. So you want to get rid of MPLS from single domain earlier than enabling SRv6 in the other domain. But for that, he was proposing the gateway. The gateway might be not very practical if you have, for example, core MPLS, but your access or aggregation domains, you want to migrate to SRv6 already. And you might need to transport SRv6 over MPLS. So how to deal with those little bit more scaled scenario where certain part of the network cannot be really migrated altogether, and it's really valuable to remove MPLS either from access or from the core. So we will start with a simpler scenario, how to do SRv6 to SRv6 over MPLS. And apparently it is super simple, and technology is here for already 20 years. What we do here is we basically establish BGP LU session between ABRs, and that BGP LU session for V6 addresses is just called 6PE, right? And a 6PE over MPLS network is running already. It's known technology for last 20 years. There is basically no difference because SRv6 doesn't need SRv6 capability all the way from the ingress PE towards the egress PE. SRv6 really needs just IPv6 routing as an underlay. A plain, simple IPv6 routing is an underlay. So here we are creating either 6PE or 6VPE, creating the path from the ABR3 to ABR5 by announcing locator of all the PEs in a right domain locators via BGP LU, so 6PE, right? And then forwarding, obviously in SRv6 domain we are using the final destination for service, which then in MPLS domain gets encapsulated with a 6PE label and a transport label of the ingress PE. Well, obviously, then at the end, MPLS will be decapsulated, and in the SRv6 domain, there is a still plain IPv6 packet with the SID of router 7 and a destination address. What about opposite thing? That might be a little bit different, right? So let's say we want to migrate or build a new core, which is going to be SRv6, but in access domain or in aggregation domain, we still have to stay for some reasonable time with MPLS. Do we have technology for that? Can we do that? Apparently, it's again relatively simple. Technology is not here from day one, and it's called MO6. We are just binding and building and using the technologies which were known and which were already introduced by Alex last time. There are many options how to do that, but let's try to imagine the simplest scenario. We are already using BGP-LU to establish end-to-end connectivity. So let's say we want to advertise the label of the router 7 or node SID of the router 7 to the whole network. And we will use BGP-LU. And BGP-LU is terminated on the ABR, which is SRv6 capable. Router 7 is advertising his own node SID with the BGP-SR, and BGP-SR is basically just sending the index in sRGB as an indicator which label should be allocated. Then router 5 will do two things. First of all, he will allocate the label for that prefix because originally and he allocates the label based on that hint, which is the index of BGP-SR. But he also allocates the SID. And that SID function is called end-DTM. D for decapsulation, T for table lookup, and M for MPLS table lookup. This way, he will advertise prefix or node SID of the router 7 with both, with the label and the SID as well. This information is received by other ABR at the end of the domain, and he will put into his forwarding, okay, label 16007 has to be encapsulated with the SID B05E000. And DTM, and also advertise via BGP-LU the original prefix SID of the router 7. And then obviously router 1 wants to encapsulate something to the router 7, and because he's receiving router 7 prefix with the next hop of the router 3, he will create encapsulation 16003, which is the node SID of the router 3, and 16007, which is the node SID of the router 7. This is forwarded. Router 2 or penultimate router of the router 3 will do penultimate hop hopping. So we'll remove label 16003, and that way router 3 will receive label 16007. And because he installed into his forwarding table the function end-DTM, he will essentially just, based on the received label 16007, he will just encapsulate MPLS packet into the IPv6 address, where the destination is the end-DTM function of the router 5. When router 5 receives this packet, he will just do MPLS table lookup, and his MPLS table lookup says, okay, this is the router 7. I need to use the node SID of the router 7, 16007, and a service label. And obviously, penultimate popping towards the router 7. So this way, we can do SRv6 over MPLS and MPLS over SRv6. And we don't need the gateway functionality, because the gateway functionality would really do the stitching of all the verbs across between SRv6 and MPLS domain. Okay, that's it. Thank you very much, and handing over back to Marius.
Thank you, Jakub. Let me share my screen again. So let's move to the demo part, and we will have a look at dual connected PE configuration and then at the interworking gateway. So here's the topology, and we configure router 4, which is in the middle, as dual connected PE now. Again, just for demonstration purposes, we have those two domains separated just to have it more visual. But in reality, that's not the case. In reality, we have dual connected PE in the same network, and we have both stacks running in the same network. So let's go to router 8 now, which is in MPLS domain. And we see we have, what do we have? So MPLS forwarding, we are using MPLS labels here. And to reach router 4, so SAP 10.0.0.4/32, we are using MPLS stack. Now let's have a look at the routing thing. Show route, your ref. So we can see we have only prefixes from router 12 and 13. Run the ref. And for this demo, we are using 65,000:2 as a route topic. Let's go back, not back, let's go to router 6, which is in SRv6 domain. And let's ping router 4 using SRv6. Just to see that it's reachable. Here we are using the locator, and yes, we can ping it. Looking at the prefixes in our VRF, this is the configuration. We are using RT1002. And looking at the prefixes in our VRF, we see only R10 and R11 here. And we can see they are reachable through SRv6, when router 8 can reach the prefixes through IPv4 with MPLS. Now, let's go to router 4 and configure it as a dual connected. So here, what we do, we create a VRF and we import and export RTs from both domains, from SRv6 and from MPLS. And for demonstration purposes, let's just add loopback interface in this VRF to see how this prefix is distributed. For BGP configuration, we configure BGP and clear with both route reflectors in MPLS and in SRv6. My lab is not cooperating with me today. It's a bit lagging. Let's give it a few more seconds. Okay, trying to reconnect. Push the BGP configuration again. So here we see this is the router 4, and we pair with RR in MPLS, and we pair with RR in SRv6 domain. Here is our VRF, and you see we allocate an MPLS label and SRv6 seed. Now let's look if the BGP session is created. Okay, both BGP sessions are up, so we can see in both domains they are created. And let's have a look what we have now. routing table. So in our routing table, we got prefixes from both domains. We can see we can reach 10 and 11 via SRv6, and we can reach 12 and 14 via MPLS. Just to confirm, we can think. And let's have a look at the SEF entry. And here we are using MPLS. Let's have a look at the SRv6 side. We can think as well as SRv6 side, and let's have a look at the SEF entry as well. And here it is using SRv6. Now, let's convert with this router for interworking gateway. So Cs from one side can get connectivity to Cs on another side. And for this one, first of all, we are using stitching keyword to stitch both RTs together. So now we are using stitching. And for BGP configuration, we are going to import the stitching RTs and re-originate them. So if we look at the configuration, we import and re-originate them to and from both MPLS and SRv6. Now let's have a look again at our prefix 12, 12, 12, 2. What we can see now. So we have a local label assigned with rewrite, and we have a SRv6 seed assigned as well. So here we can see we received it from P7 and we advertise it into a SRv6 domain. And let's move to router 6. If we look at the routing table now, let's look at routing table. E8. So now we can see we have prefixes from SRv6 side. So this is PE8, which is located in MPLS. We have prefixes from SRv6, but we can see next hop is Interworking Gateway. And let's have a look at the P6. Restart the session. So here we as well see all the prefixes, including prefixes from the MPLS side. But here again, we see they are reachable through Interworking Gateway. So the next hop is everywhere is Interworking Gateway to do the inter-domain connectivity. And being on router 6, let's ping 12, 12, 12, it is pingable, and let's have a look at the SEF entry just to confirm it. So we can see that that devices in the MPLS domain are reachable through Interworking Gateway node 4. And we can see the seed list E006 on the node 4. So let's check node 4 with this microseed. So going to node 4, show segment routing SRv6 seed. So we can see this E006 is UDT for behavior, meaning that we do decapsulation and IPv4 table lookup in VRF in our VRF. And if we check a SEF entry for this specific seed, We confirm that this is endpoint UDT4 behavior with table lookup, and we are checking our VRF. Now let's look again in the prefix 11.11.11 now, which is located in the SRv6 domain. And what we are interested in our local label, which is 24,008. And let's have a look at MPLS forwarding table. MPLS forwarding labels 24,008. So again, we can see this is an aggregate label for our VRF. So whatever packet we receive with this label, we decapsulate it and we do table cap. With this one, I finish my demo. And SRv6 is very rich ecosystem. And this is our commitment. This was our commitment to lead operators. And I let you look at the slide, but we have everybody with us, and all of the vendors are part of the microseed solution. So on June 5th, we have a SRv6 instruction-led lab presented at Cisco Live event in Vegas, where you can test, play, and see yourself how SRv6 is simple. On the slide, you can find the registration URL and the QR code. Okay, let me hold the QR code for a bit more before we move to Q&A session. Or actually, Tanner, we can move to Q&A, and I can leave the QR code on the
Yeah, that's fine. We can leave up
screen.
this slide up for a few minutes. I also just placed the link in the chat for you if any of our attendees need it. Also, this link will also be included in our post-webinar discussion thread on the Cisco Learning Network. I'll provide the link to that here in a little bit as well. As we do get into our Q&A portion of this presentation, just as a quick reminder to all of our attendees, if you do have any questions for our presenters, please submit those through the Q&A panel here on WebEx, and we will get some answers to those. So, Alexi, I do have a couple questions I would like to get to here that maybe you can expand on. Let's start with, can MPLS and SRv6 services coexist on one PE, or do I need to migrate the whole PE at once?
We don't need to migrate the whole PE at once. So this is the whole idea that we run MPLS and SRv6 together. So they coexist on the same PE, and both stacks run in parallel. And we can slowly migrate services step by step without really interrupting the services.
Let's get to another question here. How does SRv6 interworking gateway translate between MPLS and SRv6? How do these techniques ensure seamless end-to-end connectivity?
So when traffic is going from MPLS domain to SRv6 domain, the gateway will do the label decapsulation, routing table lookup, and then it does SRv6 encapsulation. And in the reverse direction, SRv6 to MPLS. So first we do SRv6 decapsulation, MPLS prefix lookup, and then MPLS encapsulation. So gateway does the stitching of both domains together, and for end users and for connected PEs, this is completely transparent.
Great, thank you. Want to get to this question that just came in from Stephen, and feel free if anybody else needs to speak up and answer as well. Stephen would ask, can you please go over the exact syntax of the BGP stitching and reoriginating syntax, excuse me. The logic of how the command syntax works is a little ambiguous.
So this is the configuration, and we can look at the configuration guide on Cisco site with more explanation with details on those commands. So what we want to do, we want to import, and then we want to advertise those RTs into the domains. So, and on CCO, we have a detailed explanation and examples on how to do that.
Great, thank you for clearing that up, Alexei. Truly appreciate it. Let's see here, just scrolling through to see if there's any further questions. While we do, wait just a moment to see if another question or two does come through. Alexei, I'd like to give you the floor and any of our presenters today. Is there anything else that you would like to cover or speak on before we do wrap up here shortly? You're still with me, Alexei?
Yes, I'm here.
Got you. Is there anything else that you would like to cover here before we
no,
wrap up here shortly?
sorry, I didn't get that. Was for
No,
me.
okay. Okay.
No, I'm okay. So that was all I wanted to demonstrate today.
Great. An additional question here from Stephen asking if the configs for this lab is available anywhere.
Well, I don't know, Tanner, if you are going to share it or we can contact.
Yeah. So Stephen, I'll cover that one. We have a customer success service that could work with you and help you out with building up a lab on SRv6. And people are actually, some of them are panelists in this session, and they're really, really knowledgeable and working directly with us. So please feel free to reach out to your customer success executive or success program manager, and they will reach out to our team.
Beautiful, beautiful. Thank you. Thank you. I'm just scanning here to check in case that I'm missing anything before we do get to the end here. And I think that about does it. Truly looking forward to this event here at Cisco Live Vegas. The registration link is on your chat screen as well as the QR code. I've also put the link to the post-webinar discussion thread in the chat where you can find some resources from today's session. Also where you will be able to watch a replay of today's session as well. I do want to thank Marius. I want to thank Jan, Miguel, Jacob, Ricardo, Bhavana, and Alexei for all of you bringing your knowledge to the Cisco community today. Thank you all for being available. We truly, truly appreciate it. If you do have a question for our presenters, we'll keep that Q&A window open for a few more moments, and we'll provide you with some answers. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. You can follow up with further questions also on that post-webinar discussion thread, and we will get you some responses there as well. Your feedback is important to us, and at this time, you'll be directed to a post-webinar survey. Please take the time to participate, and that helps us plan out some future sessions for you. Once again, we thank everybody for joining us today, and we will see you next time on the Cisco Learning Network.